Alright, in this video we're going to prove theorems about perpendicular lines. So we're going to delve a little bit deeper into what we can conclude when we're dealing with perpendicularity. Alright, to start us off, this is a diagram we're going to see a couple times this unit. What's the shortest distance between the smiley face and the line? So if the shortest distance is going to be a line that goes straight down and is perpendicular. Alright, the shortest distance is not going to be a line that starts at the smiley face and goes diagonally down to the line. Okay, shortest distance between 2 points is going to be a straight line. Drop it down perpendicular. Alright, so let's make some conclusions based off diagrams. And we can't assume anything, remember? We want to be able to prove these statements using mathematical facts. So in the diagram, I'm telling you that angle 1 is congruent to angle 2. What can I conclude? Alright, so I see angle 1 has one swoop and angle 2 has one swoop. Alright, so they're congruent. They're the same exact thing. Together, they make a straight line. So I know that angle 1 and angle 2 are supplementary. So they add to 180 degrees. And since they are both the same, since they're congruent, I know that the measure of angle 1 and the measure of angle 2 are 90 degrees. So angle 1 and angle 2 are right angles. That's what I can conclude. All right, want to recognize that they form a straight line. We want to be looking for those straight lines. Okay? So in the diagram, angle 1 is congruent to angle 2. So just like in A, I know that both of these are 90 degrees. Okay? Prove that angle 3 and angle 4 are complementary using complete sentences. Okay, so since I know angle 2 is 90 degrees, I know angle 2, angle 3, and angle 4 have to add to 180 degrees. All right, I know those three angles together have to be 180 degrees. All right, since I know angle 2 is 90, that means angle 3 and angle 4 together have to be 90 degrees. They have to make up that other 90 degrees to make the 180. Therefore, since angle 3 and angle 4 together have to be 90 degrees, angle 3 and angle 4 are complementary because they are two angles that add to 90 degrees. All right, so angle 3 and angle 4 are complementary because they are two angles who add to 90 degrees. And that's the definition of complementary from last unit. Okay? What about this next one? M is perpendicular to P. We know that with the right, it's given to us and we see the box. And N is perpendicular to P. What can we conclude about the lines M and N? Well, if you notice, if it's perpendicular, that means all four of these angles are right angles. Okay? So, if that's the case, we have all of these situations. We have that the original angles are corresponding. Okay? These are corresponding angles. All right, now the corresponding angles are congruent. That only happens if we have two parallel lines cut by a transversal. So what can we say about M and N? M is parallel to N. Okay, they're parallel lines being cut by a transversal. That transversal just happens to cut them perpendicularly. Okay, so that gives us a couple of theorems. If a transversal, so the line that cuts two lines, all right, if a transversal is perpendicular to one of two parallel lines, then it is perpendicular to the other. So what that means is if I have two parallel lines here, oh, that's a bad diagram. I have two parallel lines cut by a transversal. All right, so I'm telling you that these lines are parallel. And we know this transversal is perpendicular to one of the two parallel lines. It needs to be perpendicular to the other. Okay? This next theorem, lines perpendicular to a transversal, says if two lines are perpendicular to the same line, then they are parallel to each other. All right, and that's what we had in this diagram up here. Okay, we had two lines, M and N, perpendicular to the same line P, therefore they are parallel to each other. Okay, so let's go through some examples. I know these are you try nows. Let's talk about them. All right, determine which lines, if any, must be parallel in the diagram. So we're going to use those types of theorems and see, can we use corresponding angles or alternate interior or anything like that in order to prove that these lines are parallel. So, is S parallel to T? S is parallel to T because they are both perpendicular to line Q. Okay? So what about S parallel to U? Is S parallel to U? So I'm talking about this line and this line. I don't know anything about line U. I don't know its relationship with P and Q. So sometimes what I like to do is draw like a counterexample. U doesn't have to be straight up and down like it looks like in the diagram. This is where we can't always trust our diagrams. U could be increasing like that. Okay, it could be slanted. If that was the case, the S and U would not be parallel. All right, so could they be parallel? Maybe. But because of the information that we're given, we can make a counterexample which would show that no, these are not parallel. Okay? Next up, I'm going to erase this purple line. Next up is P parallel to Q. And I'm looking, yes, they're both perpendicular to line S. To line S. Okay, so that's going to work for there. They're perpendicular to the same line. And then last but not least, T and U. T and U. Well, again, I don't know anything about U. U could look like this. All right. So because I don't know anything about U, no, I cannot say. I'll get a different color just so I'm consistent. No, I don't know anything about U, so I can't say that it's going to be parallel to T. Okay? So let's move on. Let's do some select all that apply to questions. All right, make a conclusion. Angle 1 and angle 2 are congruent supplementary angles. So angle 1 is congruent to angle 2. And they're supplementary angles, so that means the measure of angle 1 plus the measure of angle 2 has to equal 180 degrees. And since they're the same exact thing, I know each of these is going to be 90 degrees. So I'm just translating kind of what they told me in English. I'm translating that to what we know in math lingo. Okay, so which of the following must be true? Measure of angle 1, there should be m's in front of these. But do they equal 90? I don't think 90. They're not complementary, they're supplementary. Which means B would work because they add to 180. Would the measure of angle 1 be 45? No, we know that it's got to be 90. All right, angle 1 and angle 2 are a linear pair. There's nothing that says these angles are right next to each other. It could be angle 1 is this 90 degree angle, and angle 2 is over here in this 90-degree angle. Nothing says they're right next to each other, so can't say that one either. And then angle 2 is a right angle. Well, since the measure of angle 2 is 90 degrees, I know it's also a right angle. Okay? What about the next one? Angle 1 and angle 2 are vertical angles. So if angle 1 and angle 2 are vertical angles, so I'm going to draw a diagram here. My two straight lines, I'm going to call this one angle 1 and this one angle 2. And then angle 3 is supplementary to angle 2. Okay, actually, hang on. One more thing with angle 1 and angle 2 being vertical angles, I know then that they are congruent. Okay, so that's this first step. That's what that tells me, is that those two angles are congruent. The second line says that angle 3 is supplementary to angle 2, which means that the measure of angle 3 plus the measure of angle 2 has to equal 180. All right, so let's go through these. Is 1 plus 3, angle 1 plus angle 3, does that equal 90? Well, if I know that 1 and 2 are the same exact thing, I can take 1 and swap it out with 2. So I know that the measure of angle 3 plus the measure of angle 1 is going to equal 180. Okay? So, angle 1 plus angle 3 equals 90. That's not going to work. Measure of angle 1 plus the measure of angle 3 equals 180. That's going to work. Angle 2 and angle 3 are a linear pair. Again, doesn't tell me that they are right next to each other. Just tells me that they're supplementary. Angle 3 does not have to be a part of this diagram right here. All right, so I can't say that. Angle 1 congruent to angle 2. Well, that's the very definition of vertical angles. That's because they have an angle pair of vertical angles. The angle relationship is that they are congruent. All right, and then the last thing, angle 2 is a right angle. Nothing tells me that. Nothing tells me that 1 and 2 are right angles. All right, so that one, no good. Okay, so that's how you deal with those select all that apply questions. You just each step at a time, and you see, could this be true? All right, last types of problems, and let's set them up. All right, so find the value of x that makes AB perpendicular to BC in this A, which means this is a right angle if they're supposed to be perpendicular. So if they're perpendicular, that means the x and the 8x plus 9 are complementary. They have to add to 90 degrees. So part plus part equals whole. Part plus part equals whole, which is 90. Okay, so we got x plus 8x plus 9 equals 90. If I solve this, I get 9x equals 81. Divide both sides by x, I'll get x to equal 9. Okay, part plus part equals whole. We got first part there, second part there. All right, what about in B? In B, well, I am given that this is a 90-degree angle, and because it forms a straight line with x squared minus x, I know that x squared minus x has to also equal 90 degrees. All right, I'm dealing with a quadratic here, so I need to set it equal to 0, and then I can factor. I'll get x minus 10 times x plus 9 equals 0. Break off, oh, that's super bright. You might not be able to see that. Break off each of these and set them equal to 0. You'll get x equals 10 and x equals negative 9. If you plug it in, both are going to work. Both will make this angle here equal 90 degrees. So I need to include both x's. Alrighty? Let me know if you have any questions. Other than that, start working on the practice problems. Have a good one.